planes coaxal with the given planes. Let's say we have two planes, u1 equal to 0 and u2 equal to 0. So let's say these are the now what we want to do is come out with the equation for a third plane which has the same line of intersection or which passes through the line of intersection. So let's say this is u1, u2 and let's say this is u3. Okay, so u1, we know what the equation of a plane is, r vector r times n1 vector is equal to q1 u2 r vector times n2 vector equal to q2. Let's bring q1 to this side, so this becomes r1 r vector r times n1 minus q1 equal to 0, and this becomes n2 vector r n2 minus q2 equal to 0. This relates to some other topic in maths. Any point which satisfies two equations, say a equal to 0 and b equal to 0, also satisfies the linear combination of a plus lambda b equal to 0. So if you want to know more about this, you will have to look it up in linear combination. Okay, so which means since u1 equal to 0 and u2 equal to 0 implies that u1 plus lambda u2 equal to 0. So now let's do the substitutions. R vector dot n1 vector minus q1 plus lambda vector r dot n2 vector minus q2 equal to 0. So now let's open it up. Vector r dot n1 minus q1 plus lambda vector r dot n2 vector minus lambda q2 equal to 0. Let's take q separate. So we get vector r n1 plus lambda vector r dot n2 vector minus q1 minus lambda q2 equal to 0. Here common is r, so we get vector n1 plus lambda n2 vector minus q1 plus lambda q2 equal to 0. And let's take this q1 plus lambda q2 to the other side. So if you look carefully, this is vector r and this we can write it as n, vector n is equal to, this we can write it as q. This is what? This is nothing but a equation of a plane. So let's say u3. Now let P be a point on the line of intersection of u1 and u2. Position vector would be of P is, let's say, vector A. So the equation based on this would be what? Vector A dot n1 equal to and A dot n2 vector equal to q2, and if we rearrange it, we would end up with so therefore vector a dot n2 minus q2 equal to 0 for lambda belonging to real numbers. Now this implies vector a n1 plus n2 lambda equal to q1 plus lambda q2 for lambda belonging to real numbers. So this is an equation of a line u3 which is having the same line of intersection as the u1 and u2. Now, if the same thing we have to look at it in Cartesian form, what we looked at was the vector form. So u1 equal to a1x plus b1y plus c1z plus d1 equal to 0. u2 is a2x plus b2y plus c2z plus d2 equal to 0. So, as we have seen before, u1 plus lambda u2 equal to 0. So, which implies a1x plus b1y plus c1z plus d1 plus lambda a2x plus b2y plus c2z plus d2 equal to 0, which implies, let's take this and this, a1 plus lambda a x plus b1 plus b2, again lambda b2 plus c1 plus lambda c2 z plus d1 plus lambda d2 equal to 0. Now, just as a additional information that we get from this is that the direction ratios of the normal to the above plane are a1 plus a2 lambda, this is 2, b1 plus b2 lambda, c1 plus c2 lambda are the direction ratios. One additional thing that we require, we need to know what is the value of lambda to arrive at a specific plane. For that, we require an additional condition. Something like, example of conditions are u3 is perpendicular to another given plane, or u3 is parallel to another given plane. u3 is parallel to a line with given direction ratios, or u3 intercepts an axis x, y or z at a point, or a point on the u3 plane. So basically some additional information has to be provided for us to be able to figure out what is lambda. And once we know, then we just substitute it in this equation. Of course, here I have written it as general equation. Normally, this A1, A2, B1, B2, C1, C2, D1 and D2 would be given as actual values in the form of a equation or something. So once you substitute that and you substitute lambda, you will get the equation of the plane. I think you understood that. Enough for today. Bye for now.